Welcome to the second lecture in Unit 7. The title of the lecture is Chemicals Walk the Line, and the quote that we have is "Y'all can't walk no line" by June Carter. And so in this lecture, what we're doing is students will understand how the law of conservation of mass affects chemical reactions, and students will balance chemical reactions by adjusting coefficients. The main thing about this is we are going to talk about balancing chemical reactions. A very big part of what we do in chemistry is dealing with chemical reactions and looking at chemical equations, and they have to be balanced. And so what we already know is that there's evidence for a chemical change. It includes a change in state, change in temperature, change in color, and we should already know how to write formulas from names and names from formulas. Very, very important when we talk about balancing chemical equations. Now, what we learned in the lab is that the law of conservation of mass applies to chemical reactions, and that adding mass to one side will produce more mass on the other side. And so essentially what we have is what we start with is what we finish with. And looking at this, that is the law of conservation of mass, is that we have to balance chemical equations to obey the law of conservation of mass. What you start with is what you finish with. Quantitative solutions using balanced chemical equations or unbalanced chemical equations are invalid. So if it's unbalanced, it's not going to work. It's not going to come out. So if we do not balance, everything else is wrong. So in our next unit that we have in Unit 8, when we get into stoichiometry, that's all based off of a balanced chemical equation. So all of this is about getting that wonderful balanced chemical equation so we can do math with it. And so if we don't have that, everything else is wrong. So balancing chemical equations. Coefficients are the only thing that you can change. You can only change coefficients. And remember that coefficients are the numbers in front of chemical equations. So we can have a 2 in front of NaCl, and what that means is we have 2 moles of sodium chloride. That means you can think of it this way: you can distribute that 2 to both of them. So if we put a 2 in front of this, that means that we're now going to have 2 sodiums and 2 chlorines. Now say we had something else. So say we had magnesium chloride, MgCl2, and we put a 2 here. What that would mean is that 2 would be distributed. We would have 2 magnesiums, and we would have 4 chlorine atoms that we're dealing with. Okay, one thing that you can't do is you can't come into an equation and you can't go, well, I need 2 magnesium, so therefore I'm just going to put a 2 right there. You can't add subscripts. You can never change the subscript. You can think of, if I change it, so if I make a simple change, it changes the molecule, so it can't change the subscript. Why is that a big deal? Well, if I look at H2O, H2O is water. We all need water to live. But if I change the subscript and make it H2O2, that's hydrogen peroxide. So if I change the subscript, I change the molecule. So the only thing that you can change in a chemical equation are the coefficients. Cannot change anything else. So let's look at some steps in balancing a chemical equation. When we're looking at this, it's all about the law of conservation of mass. The most important thing is the first step. Start with a correctly written equation. Majority of the time when people mess up on balancing chemical equations when they're working on it, they can't get it right and they can't figure out why they keep getting it wrong, is because they did not do the first step correctly. It's very, very important to make sure that we start with a correctly written equation. Okay, after that, we can kind of take this kind of a process that we go through, but we want to balance the metals, we want to balance the polyatomic ions, we want to balance the nonmetals, and then the last two, the hydrogen and oxygen, you kind of save hydrogen and oxygen to the end, and it really doesn't matter which one you do before the other, but normally hydrogen and then oxygen. But what we're going to see is that this is kind of an order that we go in, and it helps us and kind of gives us a starting place. The most important thing, remember, is to start with a correctly written chemical equation. So looking at our steps in action, starting with a correctly written equation. So what we have here is we have copper 1 fluoride reacting with sulfuric acid and oxygen, and it produces our copper 1 sulfate, our water, and our fluorine gas. And so what we do is we start with our equation. There it is. And then the next step is we balance the number of metal atoms on the product and reactant. So when we're looking at the metals, we look at our copper. So copper is a metal. That's right there. It's also right here. So what we do is we have to balance this out. So what I need is I have 1 copper because it has a subscript of 1, and then over here it has a subscript of 2. So to balance this out, remember I can't change the subscript, but what I can do is I can put a 2 in front of my copper, and now I'll have 2 coppers, which is what I need. The next is we balance the number of polyatomic ions. So when I'm looking at this, I have my sulfate, which is right here. I have a sulfate, which is right there. If you see the polyatomic ion stays the same on both sides, treat it as one thing. When I'm looking at this, on the reactant side, I have 1 sulfate. On the product side, I have 1 sulfate. Yay, they're balanced. Then we balance the number of nonmetals. So we're talking about our fluorines, our chlorines, all of those guys. And so when we're looking at this, we see we have 2 fluorines. Because remember that 2 distributes, so 2 fluorines. And on our product side, 2 fluorines. So hey, they're balanced too. Let's keep going. And then we balance the number of, and remember these can go back and forth. We can balance the oxygen first, or we can balance the hydrogen first. In this case, when we're looking at it, it's just a little bit better for us to balance out our oxygens first. So what we'll do is we'll balance those out. When we look at it, we see that we have 2 oxygens, and over here we have 1 oxygen. So to balance that out, we just put a 2 right there. And then lastly, since we did oxygen there, we can do hydrogen at the end, and we see that we have that 2 distributes to that hydrogen, so we have 4 hydrogen here, and we see that hey, we have 4 hydrogen there. And so it's a balanced chemical equation, and our chemical equation, which there should be a 2 right there, that's our nice balanced chemical equation that we have. So let's look at an example. It says balance the chemical equation below. So we're going to start, and the first thing we want to do is instead of going step by step, we'll write out the atoms that we have. So we have iron and we have oxygen. And then let's go ahead and look at how many we have. We have 1 iron on the reactants. On the product side, how many do we have? 2. Now, our oxygens, we have 2 oxygens on the reactant side. On the product side, how many do we have? 3. And so when we're looking at this, we can follow our steps. So our steps, we start with our metals. Let's balance our metals. Well, this guy's a 2. This guy needs to be a 2, so I put a 2 there. And see, we have 2 for our irons now. So it changed to 2. And now our ions are balanced. Now let's look at it. We see that we have 3 oxygens, 2 oxygens. Now, what's a common factor between 2 and 3? Well, 2 and 3, when we always see those, and you see a 2 on one side and a 3 on the other, the first thing we need to think of is 6. So what can we do here? We put a 2 there. Well, that distributes to the iron as well, so you got to pay attention to that, and it distributes to the oxygen. So our oxygen is now 6, and our iron is 4. Okay, so then we come back over and we got, all right, we got to balance everything out again. So how do I get this oxygen to be a 6 now? Well, I put a 3 there. It distributes to that 2, and that becomes 6. And how many irons do I need? I don't need 2 of them. I need 4. And that will change to 4. And so now what we see is our coefficients are going to be 4, 3, and 2, and that's our balanced equation. Looking at our next one, a little bit harder because when we look at it, we don't have a correctly written formula. So first we have to write our correctly written formula. Our copper is just C. Copper is just C. Oh, there we go. Cu. Silver nitrate, if it's a compound, we have to crisscross. So Ag plus 1, nitrate NO3 minus 1. Crisscross, and we get AgNO3. Then we have on our product, we have silver, produces silver, and copper 2 nitrate. So Cu, which is plus 2, NO3, which is minus 1. We crisscross, and we get CuNO3, 2. And so there's our correctly written balanced chemical equation, and we're going to go ahead and move that up to have a little bit more room so that we can balance. So when we're looking at this, what are we dealing with? Well, we're dealing with copper, we're dealing with silver, and we're dealing with nitrate. So on our reactant side, we have 1 copper, we have 1 silver, we have 1 nitrate. On our product side, we have 1 silver, we have 1 copper, and we have 2 nitrates. So let's go ahead. The only thing that's not balanced are our nitrates, so I need to balance that out. So I'll go ahead to do that on a reactant side. I'll put a 2 here. Write that a little better. So we have a 2 right there, and that 2 distributes out to also to the silver. So that's a 2, and to the nitrate, it's a 2 now. Now we have to go back and balance our silver, so we'll put a 2 right there, which makes that a 2. And we see that now we have the same number of everything on each side, a nice balanced equation. Last example, we see we have Sb4O5Cl2 can be produced by reacting solid antimony 3 oxide with solid antimony 3 chloride, and write the balanced chemical reaction for this. And so the first thing we have to do here is we don't have a chemical equation. But what we can see is that this, since it's being produced, that Sb4O5, that is our product. So we can go ahead and have that as our product, and we just need to write our reactants. So our antimony 3 oxide, our Sb, which is plus 3, oxide, which is O minus 2, crisscross, we'll have Sb2O3. Reacting with our antimony 3 chloride, which is Sb plus 3, Cl, which is minus 1, crisscross here, and what we get is Sb, not O, but Cl, sorry, Cl3. And it reacts and it produces our Sb4O5 Cl2, and these are all going to be solids, so we would have S's written beside it. So we'll go ahead and take this and pull it down a little bit so that we can have a little bit of room to work with everything, because this one's a pretty tough one to balance. And so when we're looking at this, we still want to do the same thing that we always do and break it up into what we're dealing with. We're dealing with Sb, oxygen, and chlorine. Now the trick to this is when we're looking at it, Sb is here, and it is also there. So it's 2 places. So we actually have 2 plus 1, which is 3. On the product side, we see that we just have 4. Then we look at our oxygen. Oxygen, we have 3 on our reactant side. On our product side, we have 5. So a little bit difficult to balance on those, but we'll follow our rules and see what happens. And then we have our chlorine, which we have 3. And then on our product side, we have 2. So we'll go ahead from here and start balancing with our metals. Now anytime it's kind of broken up where we have a 2 right here and a 1 right there, we see we have 4 right here. Well, what we can do is put a 2 in front, and that distributes to Sb. It also distributes to our chlorine. And so what we have here is now we have, instead of having 1 there, we have 2 plus the 2 that we have right here, so our antimony is going to be 4. And so we see that that's now balanced. Our chlorine went from 2 times 3 it's now 6. So we changed it with that 1 coefficient, we changed it 4, 6, and we changed two things. So let's go ahead and look at what else we need to balance. We see that we can balance our nonmetals. So how do we make chlorine balance? Well, we come over here and we put a 2 right there. Now that distributes to everything. Or sorry, not a 2, but we put a 3 there, and that will distribute to everything in that equation. So it changes everything. So now instead of having 4, we have 12. And 3 times 5 is 15. And 3 times our 2 is 6. So we did a good job of balancing our chlorines, but now we got to look back and go, okay, how can we balance everything else? So we're looking at our oxygen. We have 3 right here. We need a total of 15. Well, what times 3 is 15? 5. And so we go ahead, put a 5 right there, and it distributes. And we see that we have 10 plus 2 is 12. And then 5 times 3 is 15. We followed our rules and look, everything's balanced. So it's a little bit harder, but when it gets hard, make sure you follow your rules. Make sure you remember coefficients distribute to everything, and you can usually get the balanced chemical equation.